But if we start talking about intelligence, when I think of the word intelligence in the Case campus, the first person I think of is Mark Turner. And there's maybe various levels of that, but one thing is that he is an eminent cognitive scientist and founder, really, of the Department of Cognitive Science. I don't know if he'll take credit that way, but he's the founder of the Department of Cognitive Science. It's here because he was here. An incredibly wide-ranging scholar who has been thinking a lot about issues involving artificial intelligence for a very long time. I just thought that we looked at various aspects of, how you use it, and we'll be looking at what businesses are doing with it and so on, but what the hell is it? How do we think about intelligence? How should we think about intelligence? What's natural, what's artificial, and so on? How does artificial intelligence compare to any other intelligence? And I'm extremely pleased that Mark has agreed to talk about that today. So on that note, as always, I should shut up and listen to the much more experienced and expert person next to me. Mark.
Thank you, Joe. So artificial intelligence is moving very quickly. And I'm sure there's a lot of discussion to be had. So let's get through this fast. But I'll start by putting some things on the table. My BA and MA from Berkeley are in mathematics, but the mathematics department was in the same building as electrical engineering and computer science. And so beginning in 1970, 1971, there we were learning about logic gates and electrical engineering. And I was programming in Lisp and Prolog and doing lambda calculus and deeply involved in all of these things. My master's thesis was on mathematical models of the brain, including AI models. And it's fair to say that it was very heady time, strong AI, and there's a feeling that is familiar from Pythagoreans or Kabbalists that everything is numbers or form. Letters, words can be turned into numbers, numbers can be turned into anything. If we can capture it as numbers, then work it out. So music, the Pythagoreans discovered that musical intervals were ratios. You take a string, pluck it, put your finger right in the middle, pluck one, the relation is an octave. And you can do this throughout tonality. And the heavenly bodies, numbers, mathematics, so cosmology, art, maybe everything's numbers. Maybe it's numbers moving around. This is a very heady thing to feel. And I was quite surprised in mathematics to come to what I thought was a very quick in of how much mathematical knowledge we had. We had lots, but when I was younger, I thought that it was infinite and capable and would come down and had the answers to everything. But no, actually, it was a challenge and interesting to come to the limits of what mathematics could handle, including things like very large scale integrated systems like the brain. And it's fair to say that my work in cognitive science is partly driven, not by my disappointment, really, but my understanding of the limitations of AI and of the mathematics we had at the time. So the too long didn't read version is, I think that human cognition can do a lot of things, including logic and math. But those are special cases of what it can do. And in fact, human cognition is much more capacious. And one should not generalize from mathematical operations to thought. In the same sort of way that you can all do tic-tac-toe, play checkers. But you should not generalize from very simple games to think that all of human decision-making is game theory. Games are something you can play, but these are special cases. And so I think of intelligence as some agents can do some things and some other agents can do some other things because they have different mechanisms. Synthetic agents driven by computers can do certain things. Human agents can do certain things. They have cognitive abilities and they have some overlap. And the real goal for pushing things forward, in my view, is to figure out how they can work together. This is co-intelligent. Use people for what they're good for. Or this is, all administrators know this is useful. Use agents for what they're good for. How can you put these things together? This is what's happening everywhere. On the battlefield of Ukraine, in the bond houses, in medical diagnosis, in pharmaceutical invention. It's all natural intelligence and artificial intelligence working together to create successes that would otherwise be absolutely intractable. But that idea that human cognition has got some capacities that might not be captured by these mathematical approaches is not where I began. These were the days of strong AI. And sound check. So here we go. So let me just mention the interconnected trio in which I was steeped. One was the truth conditional theory of meaning. That you can't imagine how much time we've spent studying this. This was the idea that meaning, knowing the meaning of something, is knowing the conditions in the world under which it would be true. So, is Socrates immortal? Well, under what conditions would that be true? And if you know some truths, notice this is how math works. You build up truths inside the mathematical system. Then can you find other truths inside that system based on the truths you already have? This is inferential, right? Can you build forward from truths? And this came to be called the truth conditional theory of meaning. So for instance, you know all about this from syllogisms in Aristotle. If Bob speaks Chinese and Mary speaks Chinese, true. It is true that Bob and Mary can speak Chinese together. Notice that this is kind of formal. If person A can speak language L and person B can speak language L, then you can derive from those two truths that person A and person B can speak language L together. That's the essence. Now, we put these things together in truth tables. So a logical operator like AND is if A and B are true, then the following thing is true. That's an AND operator. Notice if A, by the way, 0 means false, 1 means true from the Pythagorean table of opposites. So if A is false and B is false, then X is false. If A is false and B is true, then X is false. If A is true, B is true, then X is false. Pardon me, if A is true and B is false, then X is false. If A is true and B is true, then X is true. This is formal derivation of meaning and truth. And there are a lot of operators, I won't go into them, or, not or, and, not and. Now, next bit is we all discovered that you can make electronic circuits that mimic these truth tables. So now we're talking about electricity and current, right? So here's a circuit. You build a circuit. So if the two inputs are both have current, then the output is a current. This is called an AND gate. And it works just like a truth table or an AND operator in logic. So electricity is logic. So if thought is reason and reason is logic and electricity can do logic, then electricity can think, right? And we built hold on. So we built lots of these. See, we built lots of these. So you can't imagine how many different things we put together in Evans Hall, and then we programmed them in Prolog and Lisp, and then we blah, 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 blah. Here are all the gates. Bertrand Russell and Alfred North which can be used in it. Any other operator can be composed out of a constellation of not and gates. So it's your universal thinker. And we built these things, right? So this is the basis of symbolic AI, developing languages in which you could say, if this and this, then output that. If this, then that. If this, then that. If not, or as we say, else if, this, then. So you began to go through recipes, processes, algorithms. They're all like syllogisms. And you build these in languages explicitly. You're a programmer, right? The third part of this comes from my days studying neurobiology, which everyone now calls neuroscience, is that a neuron, in fact, takes inputs in the form of spikes. These are little electrical currents coming down the axonal arborization, which impinges its synapses on other neurons, and that changes the voltage differential between the inside and the outside of the cell. And when that differential hits a threshold, guess what? The neuron fires a spike out its axon. So guess what? No spike is a 0 and a spike is a 1. So now neurons are like logic gates, and this must be how we think. Now, we use a lot of good old-fashioned AI in my lab, Red Hen Lab. It's wonderful stuff. Programming. So for example, we work on multimodal communication, and we have vast amounts of data, huge, incredible amounts of data from all kinds of things. Here's just some news.
There have been two
So that will be a question that's raised, but
curtain
we really need to be careful because we may be
information
saying
battle
in
with
a few
foreign
minutes or
media,
a few hours.
which provide alternative views on world news, views which often run in contrast to the coverage of events by the U.S. mainstream media.
We are in an information war, and we are losing that war.
Okay, we annotate this stuff by hand, but can you imagine 1 million hours of recordings? Wow, easy, right? Plus Roman sculpture, Renaissance painting in all kinds of languages. So here's somebody using a little bit of computer.
Yeah.
We are in an information war, and we are losing that war. I'll be very blunt in my assessment. Al Jazeera is winning. The Chinese have opened up a global English language and multi-language television network. The Russians have opened up an English language network. I've seen it in a few countries, and it's quite instructive. We are cutting back. The BBC is cutting back.
Some
Okay,
5
the
years.
point is, if you want to study human communication, how do you do it? Well, you get vast amounts of data, but what's a human to do? Just sit and poke around? Could we get a little bit of help? Notice, by the way, you can
Am
get all the
Vorabend
data
des
in all
Referendums
kinds of
ist
languages.
Griechenland tief gespalten.
Pour chaque musulman. 2000 personnes à Téhéran.
Nikoli 150, aktuálně už 171
Now, this stuff comes with closed captioning. And we can use good old-fashioned AI to turn the speech into text, to try to pick out the gestures. In other words, can the human researcher get a little bit of help from a co-pilot that will analyze a lot of this stuff for you? And indeed we do. So in Red Hen Lab, by the way, you can get a summary of all this in this the German Journal of Artificial Intelligence, Künstliche Intelligenz. You can go to my website and download this. Well, in Red Hen Lab, and by the way, this takes no human work. All of this is automated. All of this is by computer AI. Captures all this stuff, put it in, mark it for syntax. So, and you're getting cheered on by people around you. So it marks it as and as a conjunction. You is a personal pronoun. So it analyzes the syntax. That analysis is good old-fashioned AI. Maybe nobody's ever seen this slide before. Right now, 150 hours easy of data a day are being ingested automatically and processed by good old-fashioned AI. And then you can use it. So for example, imagine you want to study the I'll call it the absent construction. That's things like in this time, absent federal energy, we will fail. So what is that in English? It's got very weird properties, very weird syntax. It doesn't seem that way to you because you're masters of language, but in the same sort of way, seeing is extremely complicated, but you don't have a clue how you do it. You can't look into it. And in fact, if you think you know how you see, almost everything that's common sense about seeing is wrong. But similarly, you're masters of things that you can't explain, like the absent construction. But a linguist looks for patterns. So you can type in, hi, blah, 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 a little bit of code, absent, blah, blah, I want it to be just this part. You get zillions of hits immediately. It gives you the context and you can click on it and you see the actual recording. Okay, good old-fashioned AI. But now, back in 1970s, we also had a different river of AI. That was connectionist AI. Now, imagine your retina. Your retina takes in photons. They're just photons. And somehow you see things. How does that happen? Well, it is not because a programmer came and figured out how it happened and programmed your brain. And if it wants to be a little different, changes the program, right? Now you have to learn, but this idea of, wait, can we take inputs and have them deliver outputs? Just basic idea, right? 3 and 5 are the inputs, 8 is the output, right? Can we get things that do input, output without having explicit coding in the middle? So here's a perceptron. These were way back. I studied this in the 70s. And the idea is you get some inputs, and that input could be a word, 3 words, input 1, input 2, input 3. And you want some output, like easy, here's an input, may I have coffee? Output, yes, right? Can you get something? Or, hi, here's a handwritten 3. Can the output be, this is a 3? Can it recognize that this is a 3, right? Well, this was inspired by neurons. They explicitly inspired by neurons. They get inputs, they have an output. A perceptron takes the inputs, embeds them by turning them into, all the Pythagoreans in the room are going to love it, numbers. Now, how do you turn an input into numbers? Well, it's easy. So for example, suppose you take 52,000 words and you want them each to be a number. Well, you turn them into a vector. You take a vector is just a sequence of numbers. Take vectors that are each 52,000 characters long, right? And the first word is 1 followed by a whole bunch of zeros. And the next word is 0 followed by 1 followed by a whole bunch of zeros. And the third one is 0, 0, 1 followed by a whole bunch of numbers. It's called one-hot encoding. It's a really dumb way to do things, but you get the idea. You can turn inputs into numbers, namely vectors, just a sequence of real numbers. So you have your inputs, they're numbers, but you want to know how important each one is. So you multiply them by weights. So if here's a value and I multiply it by a half, and here's a value and multiply it by a 1/4, then I've viewed this as only 1/4 as important to contribute to the output. And that's a perceptron. And you can do basic things with a perceptron. Note that this is all first semester, sophomore year, linear algebra, right? You remember linear algebra? Why is it linear? Because y equals mx plus b is a line. The m is the slope and the b is the y-intercept. You remember painfully from junior high school that if you had x plus 2y equals 4 and x plus y equals 2 simultaneous equations in two variables. You can subtract them and get y equals 2. But since x plus y equals 4, or whatever side, that tells you what y is. And so now you know there's this one, it's actually a vector, it's coordinates. It's two numbers, but two numbers in a line is in a row is already a vector. You know that there is a point where these lines intersect. So from the slope, you can tell they're either the same line or they're perpendicular lines or they intersect in one point. That's linear algebra. Now you understand a vector of two places, so you can understand one of 10,000 places. You don't care. It's just all the same. And you can multiply vectors by each other. You can get lots of vectors in a matrix and multiply the matrix times the vector. But this is really straightforward mathematics, folks. We are not talking about solving Fermat's last theorem. This is, if you graduated from high school, you can learn basic linear algebra. There are books like Linear Algebra for Dummies and the Chomps Outline series for linear algebra. Now, this gets complicated fast because you can have lots of nodes and lots of weights to multiply by the activations from one node to a layer and to the next layer. And you can also not multiply, but hey, I don't really like what this layer is doing. I'm going to add a bias, which is you subtract or add a number. And so these are the weights and biases that are in a network. The weights and biases are parameters. So current AI, you will have heard, sometimes has things like 200 billion parameters. It really does. So it's very, very huge. And there are a lot of nifty tricks in here, but I want to reassure you that it's all sort of linear algebra. Now, where do you get the weights and the biases from? This needs a little bit of vector calculus, namely partial derivatives. What you do is you take a bunch of data where the input and the output, you know the input, you know what the output should be. And you just start off with a bunch of random weights and biases. But you tell the machine, I want you to arrange it that for all these inputs, that's the output you get. Well, you could do it. You could sit around adjusting weights and biases, but it's impossible. It's just, but it's absolutely obscenely complicated, right? So what you do is you create a function over here called the cost function, which means how badly did the computer do? Train you in the cost function in 60 seconds. And then the cost function says, now go back and adjust all the weights and the biases just a little. Okay, and you do, and then out it comes. Now your new cost function, you do that, zillions and zillions, it costs billions of dollars to train these things because it's a zillion operations of linear algebra that can only be done by GPUs. And so this is XKCD. This is your machine learning system. This is how you set the parameters. You get your weights and biases. Yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side. What if the answers are wrong? Just stir the pile until they start looking right. That's what happens. You have gradient descent and back propagation and things that readjust the weights. And you do this again and again and again. Now, things would have been more complicated if I had talked to you like 3 years ago, because at that point, there are lots of neural nets like this, convolutional neural nets, recurrent neural nets. But in 2017, there was a paper that was published that changed everything. It's called Attention is All You Need. Famous. And it created the transformer architecture. So if you want to get into AI, learn what the transformer architecture is. Attention is all you need. And it's this. This is a transformer architecture. So I'm going to just tell you this for 1 second. That is, you encode your inputs with some kind of vector. That's an embedding layer. And what you get are vectors, and these are vectors in an n-dimensional space. And by the way, vectors that are really close to each other tend to be similar in the outputs, and vectors that are very far apart tend to be dissimilar. And then you might want to do things like have a placement layer. So for instance, if I say, my name is Mark Bernard, well, you want to know that the my isn't just a my, it's in a certain spot. And the name is in a spot. Well, that's okay. There's a nifty little sine and cosine assignment you can do. So you get a placement embedding. And these are just numbers. And you're adding or multiplying these vectors. That's all you're doing. That's what you, lots and lots and lots of it, that's what, lots of subscripts, lots of superscripts, that's what you're doing. And you might feed that forward, but now there's this nifty thing called an attention layer. And the attention layer is where things look at the vector bundles for the other things in the context. So if I say the queen died last year versus he moved his queen across the board, you're going to get different meanings for queen, right? So in the attention layer, all of these things say, hi, I have these vectors and I'm looking for that vector. And the other thing says, oh, I have this vector. And you're pulling around in the n-dimensional vector space, the meaning of queen, right? And you get a better idea of what the numbers should be. And then you do it again and again and again. So that's a multi-headed attention layer. You feed some stuff forward, and there are lots and lots of bells and whistles here. But what I want to tell you is it's linear algebra, first semester, sophomore year, linear algebra, plus first semester, sophomore year, vector calculus, like the gradient, div curl grad, and all that. Now, so on the one hand, we have the explicit encoding with logical operators in languages meant to do that. Input, output, recipes, processes, algorithms. In the other, we have we are going to use an awful lot of trial and error, really clever trial and error, to adjust the weights and biases, all these parameters in this incredibly massive network. Now, notice, see, I'm mainly a linguist. What linguists do is try to find patterns in language. You saw me talking about, in these times, absent federal funding, we won't. Okay, what are these patterns? How do they work? They're immensely complicated. It's difficult for human beings even to notice that they're there. It's difficult for linguists to notice they're there. But these things, the large language models, ChatGPT, has been trained on trained. I mean, their weights and their weights and their biases have been set by this training of input, and this is the right output, on levels of data that all the linguists who have ever lived could not pay any attention to if they all had 1,000 lifetimes each. Massive, impossibly staggering amounts of data. Now, the numbers in there. Can the linguist trick these things into kind of revealing some stuff about, in other words, can this thing be an assistant to you as you're trying to find patterns in language? Well, we wrote a book about that.
Artificial intelligence is an incredibly hot topic these days. In this element, we show how a conversational AI based on a large language model, an LLM, can assist the construction grammarian and the frame semanticist in particular. An AI LLM chatbot is a text generation system trained on vast amounts of text. To generate all this text, it must be able to find patterns in the data and mimic some linguistic capacity, at least in the eyes of a cooperative human user.
So, co-intelligence, if you want to see this particular project, go get that book or just write to me, I'll send it to you. Now, there are lots of sophistications. You can say, okay, here, I've got this system, but now I don't like it that you don't know some things, and I don't like it that you tell me other things. So here's a set of holy texts. These are the Bibles. This is retrieval augmented generation. I want you to use this for guidance and tell me if it's in these things. And if it's not, just don't tell me anything. That's called retrieval augmented generation. Fine tuning is when you take one of these models and you say, you're pretty good. But I have a particular little body of knowledge I want you to get. And guess what? I've got a lot more ground truth created by human beings. Here's the input. Here's the output. I'm going to train you on this. This is called fine tuning. So we're changing the parameters. And so I want you to get a lot better at this kind of thing. There are other ways to do it. You don't always have to change the parameters. Under low rank adaptation, you can put in a little tiny matrix for a layer and just train that, but skip all that. So we, for example, took ChatGPT 4.0, Gemini, Claude. I did this for a conference a couple of months ago in Montreal. It only took a couple of days to do this, but that's because we got to use, I'm a member of Case Western Reserve University, high performance computing, and has awesome GPUs, and they hand them to me and I do this. So you can do it really, really fast. And so we gave it a couple of little textbooks and said, use these to comment, and it did worse. And the reason for that is, as we predicted, that the textbooks give you little simple examples so you can get the principle, but they don't really mean that that's how to do it. It's much more complicated in practice, right? Whereas ChatGPT 4.0 had been trained on zillions and was using all of that and was not under the commandment not to use that, just using text. And so it did worse. But here's the great one. We took ChatGPT 3.5, which is much, much worse than ChatGPT 4.0. And in a couple of hours of fine tuning, we made it able to work better than ChatGPT 4.0. So I'm trying to give you a flavor of how do you develop a co-pilot? How do you develop co-intelligence? Now, there are lots of differences, and here's where we're going to kind of end. So people die, computers don't. Once you teach the computer something, it's got it. Sure, they may get screwed.
Just quickly, how many computers are 80 years old?
None.
Just.
Oh, no, that's, but who cares about the device?
Okay.
You just clone it to another
Okay,
device. As
okay.
we always say,
All right.
your device is nothing. It's your data and your operating system. By the way, I hope you're all backed up. If you're not backed up, the archangels backup are gonna come and get you. Right. So you can replicate. But there are other things. One of the things I say is, listen, you want to know what's adapted for what? Go out to the forest and put a bunny there and open your laptop and put the laptop there and come back in a week and see which one is okay. It's the bunny, right? Different life courses. Human beings have bodies, they have emotions, they think by acting, they're always embedded in contexts. You can do learning one shot. You see a face, that's it. You've got the face. You could see it tomorrow from the side with the hair let down and sunglasses on, and you still recognize the
Well,
face.
some of us can and some of us.
Okay, but point is, you need vast amount of data to get anywhere with AI. Truly unimaginable amounts of grunt work. But I want to focus on creativity, and this will be my last example. Human beings have the ability to come up with things that have never been here before. So here's a riddle. A monk arrives at the bottom of a mountain path a few minutes before sunrise. At sunrise, decides to walk up the mountain path, reaches the top at sunset, sits down, meditates all night, rises the next sunset, walks down the path, which he reaches at sunset. Question. Without assuming anything about speed, nothing except that he doesn't leave the path. Is there a spot on the path that the monk occupies at the same time of day on the two different days? Now, a lot of people find this quite difficult. It's a famous riddle. But you can do this by taking the two different paths, things you already know, see the ascent and the descent, and I did this just in Flash. And you can say superimpose them. And then at dawn, you've got two monks, and however they move, they've got to cross on the path somewhere. And the way you've done the projection, that will be the same time. There are details here, but notice you can convince almost anybody that this is true. What you've created is something out of two things that existed before that has emergent structure, like two monks. It has a meeting place. In neither of the inputs is there a meeting place, and so on and so forth. You can get, it's also false, but you can get truth for the network out of falsity. There are mathematical proofs of these. I have put forward 3, but as J. Alexander and any number of other people at the Fields Institute have shown, mathematics is particularly designed so that the notation in mathematics drives you to do the kinds of blending that produce these proofs. Or you want to show that somebody was really fast and set a world record in the mile. So what you do, this is what the New York Times did, is you put this person, Hikam El-Garouche, on the track, and where the fastest milers of the last decades would have been when he crossed the finish line. Now notice, I mean, Roger Bannister never met Hikam El-Garouche, but now you can say things like Hikam El-Garouche defeated Roger Bannister by 120 yards, because in the blend, in this thing you have put together, now there's structure that you can roll with. Now this sounds strange, but it gets picked up. So here's, now showing you Jesse Owens running against Usain Bolt and emergent structure. Let me point something out. In this mythic race over history, Usain Bolt wins. Jesse Owens is crying. He's crying, depressed. Now notice in the input he comes from, he was not only the winner, he was the world record setter in that input. Down in the blend, where you're doing the truth, he's the loser, right? This is emergent structure. Human being, I'm showing you pyrotechnic weird examples so you get the idea. But in fact, what I'm going to say is you do this all the time for all kinds of things. This is the basis. If Clinton were the Titanic, we said when Bill Clinton was having trouble with Monica Lewinsky, but he wasn't having any trouble. Now, notice this is supposed to be metaphoric, but the one thing you know about the Titanic is that it did sink. The one thing you know from physics is an iceberg can't sink. It's made of ice, it floats. It can be submerged, but not sunk. So in the blend, you have physics you can't have any experience of and going against everything that you know historically, right? You're not projecting that from the source to the target. No, this is coming from the political sphere. People do this kind of stuff all the time. In language, this is something I lecture about all the time. In language, we invent new forms of language all the time. And I mean new constructions. I'll just give you one example. It's because now. So for instance, somebody's going into a cafe and you say, why are you going into that cafe? And they say, because caffeine. Everybody understands that.
I gotta ask, how many people do that? Because I never do.
Of course not. You also don't, you also, exactly like me, I say things are based on. I don't say they're based off of or based out of. Do you say based out of, based off of? Okay, you can find it everywhere. Now, the point is, it's a special construction in the sense that the understanding is the noun has to carry enough meaning with it that you could work out all the inferences. Now, when I say caffeine, I am saying, I think you know enough about caffeine in order to be able to compute this, right? So even if you hear somebody, why are you going into that cafe? Because Alexander, and you have no clue what Alexander is. You think the person saying it to the other person thinks that if you know Alexander enough, you will know why I'm going into this cafe. Now, the point is, we are eating the food off our children's plates when we overfish. We eat not only today's fish, but tomorrow's fish too. We're eating tomorrow's fish. Human beings do this kind of thing all the time. That's what we're doing right now. That's what makes it possible for us to do these kinds of things. Can you get a co-pilot that lets the human being linguist work with knowledge and see how it can blend? So one of the things we're doing is taking the computer encoding. It's just a bunch of XML files. There's nothing to it. It's not even code. And seeing whether we can blend frames and we can talk to the AI about frames and get it to do things that the AI and the symbolic coding can't do. We've built several of them. One of them is, hi, you can talk to the AI. This runs right now. You say, hi, propose a new frame. Now, a frame is a bundle. Like if I say, I have to call my stockbroker, you know that I'm probably talking about buying and selling assets. And the buy-sell frame is something you know, not just encyclopedically. If you're a native speaker of English or almost any other language, you're expected to know the buy-sell frame, right? So stockbroker calls up that frame. It would be a surprise to you if I said, well, what are you going to buy? And I said, oh, no, he has the best recipe for chocolate pie. So I go, see, that would be regarded as misleading, but I didn't say, right? It's that I said stockbroker, I relied on you to activate a certain frame. And if I don't use that frame, then I can be regarded as misleading you. We also say, hi, chatty AI, can you do frame blending? So we've got a frame blender, and you can ask it to blend frames, right?
Frame blending window.
So,
And you
for
can
example,
use
you
tab
say,
to
pick a
switch
couple
to
of frames
evaluation.
that you've never blended before and make some blends. So in this example, it picked up aging and travel. And it comes up with these examples like, over the years, grandmother's wrinkles deepened, each one a stamp on her passport to a new life.
Wow.
Okay? Now, the point is, that's not because this system was trained on data. It's not because somebody probed it in logically. It's okay. We love phones. This is an AI talk. That's AI. It's not because somebody did the logic to put it in, and it's not because it learned it from the training data. So co-intelligence, that's where I am. And now let's have a discussion about the brilliant, glorious future of co-intelligence and what kind of public policy we should have.
Wow. I'm against it.
I know, that's what. And you know that doesn't matter, right?
Oh, absolutely.
Okay.
No, I also think we should have national health insurance.
There you go. Oh, no, there's much more chance that we'll have national health insurance
Right.
than that the AI is going to disappear.
Right.
So what is AI doing for us now?
Well, for me, I'm a researcher. I'm a cognitive scientist. I, give talks like this. I publish papers. I, do YouTube videos because we want to understand how human beings think, how the brain works. And the truth is, I teach neuroscience. I teach AI. I teach linguistics. I read everything I can get my hands on, and we have tons of people all over the world in cognitive science and psychology and every place else trying to study this. I would say that any great professional who's being honest about the state of our knowledge about human thought will tell you that this science is embryonic. We are in the early days, and we are gradually putting things together. If you want to know trigonometry, I can teach you trigonometry, A to Z, alpha to omega, no problem. It's all there. If you want to start talking to me about how humans think, how they think with each other and so on, sure, I can talk a great story and give you lots of things and so on. But man, is there a lot of work to do. Can the AI see, when we're trying to figure out what human beings do, all we've got is data. But we have very limited attention. We have to go to sleep. We die. Can some jobs be delegated to the AI to help us? That's what it's doing for me. Now, there are bad versions of this. If you want to blow up your enemy, can AI help you? You bet. Sandy?
So going forward.
Sandy Russ, the distinguished university professor of psychology. So she faces the same challenge I do.
I do. And going forward 50 years, okay, 50 years, do you think that AI will be able to be as creative as humans are right now? And the example you just gave, putting the two frames together, that was a very creative output. And, so what do you think going forward?
Okay. You won't be surprised that I lecture all the time on creativity. The first question is, what is creativity?
Yeah.
The one thing I would say is, you have to be aware of the ELIZA effect. Human beings, we have no direct access to anybody else's mind. I think Sandy has a mind. All that's happening right now are some photons are hitting my eye and some longitudinal waves are hitting my ear. And out of that, I create a mind for Sandy. I cannot look into her mind. Sure, I can see her eyes. I can hear her words. That's all very, very indirect. But I take her performances, the forms she produces, as trying to prompt me to construct a meaning. And I think she's got a meaning in there. And she came up with that, right? I'm always projecting my assessment of creativity or just competence or just performance onto other people, and so are you. So one thing we could say is the bit about grandmother's wrinkles isn't creative at all because the machine doesn't understand anything at all. But you find it creative. Now, so I'm a consumer, I'm a researcher. If I want to find patterns and it finds patterns for me, or I say, how about this? Is this pattern right? Do you find counterexamples, blah, blah? Well, I think it's good because it has value to me. It is doing something for me that I want it to do. So if you ask 50 years from now, by the way, I'm writing a book now with Chago Torrent called Future Mind, which is how bizarre it is that human beings can imagine futures that are not just like, I ate a pastrami sandwich yesterday, I'd like to eat a pastrami sandwich tomorrow, which is a timestamp on a memory. But you can think of worlds that have never existed, machines that never existed, things that never existed, policies and contracts and so on that never existed, arching across causation, agency, time and space. It's absolutely staggering that human beings can do this, and you do it all the time. Where will I go to college? If I get that major, what degree will I have? And after all, what's going to happen in Ukraine? Okay, so how do you project the future? Just it's not just what I think is going to be there in 50 years, it's how I think that something would be there in 50 years. Well, in Silicon Valley, there are a lot of people like the famous author of situational awareness that says, just follow the trend lines. We've been making this amount of progress, just extend it. Now, come on. That's one way it's called extrapolation. That's one way to imagine the future. But, we know lots of things that go like this and even things that go like this headed down. What I will say is if creativity or value or use is assessed by the consumer who wants to know, can this thing help me do something I want to do? Which could include writing a poem. Then yes, it's going to be very, very, very big. If you mean, can it actually do blending to create emergent structure that has never existed before? It may be able to put things together that you take as having emergent meaning. But at this point, I don't have an analysis according to which it would have a purpose of doing that, or an assessment that it can do that, or a sense of its own self. By the way, one of the big differences is you all have purpose. Human beings have purposes and goals. You leave a human being alone, they're going to do stuff. They want to do stuff. You leave the large language model alone, it just sits there. Unless you prompt it, nothing's happening. Lots of differences here. So there's a hand over here, and I hear somebody in the, yeah.
There are people who say that AI is going to be the downfall of humankind.
Yeah, they're called doomers.
So I'm curious, A, why do they think that? B, do you think that? And is there anything we could do to prevent that if it is at all possible?
Yeah, so I love this conversation. I read all this stuff, but full disclosure, I don't have anything to say about this that's expert. I don't have any more insight into this than anybody else I've ever met. But it's quantized in the world. This is called, you say, what's your P-doom? Probability of doom, right? And there are plenty of people who say it's absolute. And the reason they say it's absolute is this stuff will go from being not just a responder, a kind of interlocutor. It will start to have agency. So for example, suppose you want to make a dinner reservation at your favorite restaurant. You say, hey, make me a restaurant for 4 when you can get it on Thursday at Aetna. Now that means it has to call Aetna. And it has to book, might have to, if you wanted to pay your bills, if it can take action in the world, then since it's always trying to optimize its performance and has no value placed on the optimization, maybe it will decide if it got rid of you, then it wouldn't have to, right? Right. So this is sort of how the idea goes. So some people say, no, we just pull the plug on it. But many people who are very talented say, no, you can't pull the plug on something more powerful. So Jeff Hinton, godfather of AI, said it took evolution a long time to get mothers to respond to babies. The weaker thing is in control of the stronger thing. That's not going to happen with AI. AI is going to do whatever it wants to do to optimize, and you don't know what it's going to optimize. So, and I can walk this all the way down, right? To come on, give me a break. This thing is, it doesn't do anything if I don't tell it to do something, right? There's also sort of this notion from Carl Sagan that you can have one little event that's going to wipe us all out. I take the view this is a very tough species and might, in any conditions like nuclear war, be a lot of bad things that happen, but nothing's wiping this species out. So my P-doom, which is just kind of a parlor, is really low. And it's vanishingly small. And I get upbraided for this by the doomers. I would just say that in Washington, in California, they're all trying to figure out what kind of guardrails and suppressions we can put on AI. And it's an open policy issue, and I'm happy to talk about it, but I don't feel that I have anything expert to say.
I just want to point out that that somebody really ought to do the analysis of how much energy.
Oh, tons. They've done that analysis. No, they've done that analysis. And in fact, so much that there are whole industries of trying to train the AI with less energy. Mini batching, it's just on and on and on and on. Also, but wait, inventing new forms of small nuclear energy plants so that you can plant them right next to the server farm so you don't have to sit it over. This is a big deal. If you want to talk about the public policy of energy, how AI plays into public policy of energy is a very big deal.
And of course, and one of the issues that's out there is anybody calculating out the cost benefit analysis of all the wonderful things you accomplish with AI as opposed to the costs of the energy.
Hey, Mark.
Faye Powell had a question that was on the chat. Can you pick it up? Okay.
Can you just read it? I'll stop sharing my screen so we can all just. Hello, Faye.
Can you read it?
Yeah.
Faye is muted. Yeah, go ahead. Read it.
She put it in the chat.
Read it.
Okay. What do you have to say about ethical issues associated with these tools, lack of consent to have data used to train models, environmental consequences of large computational systems, exploitation of workers in the global south to perform tasks necessary for training?
Yeah, vast ethical issues. What I would say is I get this at home. My wife is a famous author, Newbery Honor Book Award winner, big series. And she found that all of her novels were used to train ChatGPT because there was a list. And she was paid nothing for this. If you look at Tumblr, there are oceans and oceans of concern about using intellectual property. Now, of course, in my work, I, like all of this red hen data, I am not using somebody's intellectual property. I'm using stuff that we're allowed under the US Copyright Act to use for research. However, the large language models have been trained on other people's IP. So in fact, to the extent that I'm fine tuning Llama 3 or something, yes, we are using that. And as people say to me, you've got to figure out a way so that the artists and the inventors and so on can continue to be rewarded for their work. And yes, exploitation, the people who do reinforcement learning through human feedback and have to deal with all this stuff. What I would say is there's a podcast every Friday by Kevin and Casey. They're sort of the click and clack of AI and click and clack of tech. If you don't know what click and clack are, you can ask ChatGPT, it will tell you. And it's at noon. Kevin Roos is the tech reporter for the New York Times. So I listen to it every Friday, and there are tons of, and it's fun. You can listen to it while you're, doing the dishes or things like that. And vast amount of very high level consideration of ethical issues in that. And I just refer you to Hard Fork and to the papers that they reference. And we have experts here at CASE. I don't have anything insightful to say beyond that.
Phil, you could take like, that's 3 more to start with.
Phil,
and then Brian, and then.
Mine's a quick one. You mentioned there was this groundbreaking paper a few years ago. My question is, who wrote it and why don't we know about her?
It's called Attention is All You Need, because it included these attention blocks, and the attention blocks very simplistically are where the inputs pay attention to the other inputs that they're with. This, I gave you the silly example. He moved his queen across the board as opposed to the queen died last year, right? So in the attention blocks, it's just massive amounts of computation and training, but everything's paying attention to each other. And then they do it again, and 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 they do it again in parallel. So it's a multi-headed attention block. And there's an encoding. So you say, I am Mark Turner, and the encoding goes up, and then you take the output, you put that into a decoder, and the attention block has to be a little different for a reason I could explain. And out comes Sono Marco Bernardo. Right, so it takes the input in one language and it gives you an output in another language. And this architecture of neural network has captured everything. And all of the AI that you're hearing about is on a transformer architecture. So all y'all, if you want to get into this, the thing to do is go learn about a transformer architecture. So everybody in this field knows all about it and has read it and makes inside jokes about the reference to the Beatles, love is all you need, attention is all you need, that kind of thing. On the other hand, and it's cited in all the YouTube videos and things like that. On the other hand, it was
TED Talks.
TikToks.
TED Talks.
TED Talks, but also TikToks.
Okay.
And on Tumblr, but it's extremely compressed. So it was written for insiders. So if you don't already know what a query vector matrix is, and a key vector, and a values matrix, you won't understand what's going on. The query is when I said, this little bundle says, hi, I've got these vectors and I'm looking for this vector, and this over here says, well, I've got this vector. So they're not really talking to each other, but the math is interacting with the math. And that was produced by Google. And I am going to tell you that, of course, it was a multi-headed team. And this is one of the things that we talk about in the academy, because in AI, although you got great math in the academy, and we do awesome things here, and we have AI in the academy. The industry research labs are often now in AI where the cracking breakthroughs are made. Sure. And this, talking about what's the future going to be, one of the things that's going to happen to our university, and better get on it fast, is to think about how research actually happens in this field. The idea the university does its thing and the corporations do their thing, that's over. So Ashish Vaswamy, Noam Shazir, Nikki Parmar, Jakob Uskoret, Lillian Jones, Aiden Gomez, Lukács Kaiser, and Ilya Poloshukin were the Google team that produced Attention is All. And it really, this is like, it was like a karate chop to the entire field. Everybody went and read it, everybody changed what they were doing.
Thank you.
Sure.
Okay, I did.
I'm hanging around. You can
Yeah.
all leave. It's 1:30, but I'll stay as long as
Go ahead.
anybody.
I had a question regarding kind of the development of AI as a field. So we were talking about kind of like the doomers earlier and like the
Yeah.
idea of maybe AI leads us to doom. So if we continue developing AI to like a kind of perfect point almost where it gets very, very, very effective, say,
Right.
ideally you could put it at like 100% on any sort of test, it would never make any mistakes. My question would be, is it worth it to do that, given that, like, the analogy that I like to think of is it's either Terminator or WALL-E, where either the AI either ends everything,
Right.
or it becomes so useful that humans become useless. So is there a point necessarily in developing AI? And if there's not a point in developing AI, at what point should we stop and say, all right, this is good enough?
Yeah,
So that we don't-
I would say, who's this we? This is a policy question, right? Markets make.
Right, who
decisions.
gets to be we?
Yeah,
Yes.
who decides? Markets make decisions through the interactions in the market. One thing we see is that AI in the market has really succeeded. They're now talking about raising $1 trillion to train the next large $1 trillion to train the next large language model. That may sound insane, but it isn't.
This doesn't mean that there's applications which will actually make profits in other markets.
Right.
But in the financial markets, it has succeeded.
I'm not talking about value investing. I'm talking about a beauty contest. The other thing is governments. The governments have a role in setting this policy. So the question I would say in all of this is who decides. Now, for me, remember, I'm looking at to what extent can these things be co-pilot, can let me do research that is otherwise intractable for my discipline, that you just can't get a handle on. And the answer is it's extremely valuable. So people want to learn this and how to do it and what's the thing. What I would say about if we get to a certain point, one of the problems we have is that the early days of AI, nobody was paying attention to deep learning and machine learning. I used to teach GPT-2 and so on. I teach cognition and computation. They would learn it. They didn't really care. Okay. What happened is when ChatGPT came out and you could talk to it interactively in a conversation because it had a large enough context window that it could remember the history of the conversation. Suddenly, everybody went gaga. I was everywhere. I mean, suddenly everything everywhere was talking about ChatGPT, but it was trained on the internet. So people were worried about, hey, it tells lies. Well, of course it does. Garbage in, garbage out. Like, and you tell me something. So it tells you something. A lot of that was, just early day demo, proof of concept. On the bit about getting things wrong. Now, for instance, the kinds of things I do is you use a mixture of different AIs to do the thing you want to do. So you'll often hear, for example, that these large language models are not very good at math, and that the high school students asking, what is the derivative of acceleration? They get that answer right. But if they ask you, what's a Poincaré sequence in this, then they get it wrong. Well, that's because they're just asking the large language model. But guess what? ChatGPT has Wolfram Alpha as a plugin with the Wolfram Alpha API, and Wolfram Alpha is awesome. So I have no limit to my name. As a productive theoretical mathematician, I've never done a damn thing. I thought once I had a little something, but somebody got it earlier. But I can do it, right? If my life depended on it, and somebody said, your life depends on this, you have to solve this, college level math problem. But not you. You can either talk to ChatGPT 4.0 to interact with Wolfram Alpha, or we have great math majors here. You can randomly pick a math major at Case to work it out. There's no doubt that I'd go with Wolfram Alpha, right? And at this level, I know what I'm talking about. Similarly, I've got 54 years of working with the Bash shell in Unix, Linux, right? but there's just all kinds of stuff. Anytime I put in a command and it doesn't work, I throw it into the AI and I say, what's wrong with this command? And it tells me, and then I learned, it took me 6 months to do this. I don't even have to put in the first shot. I just tell it what it wants to do and it tells me the commands, right? On the code, I don't know a senior coder that doesn't have one of these open and using it all the time. And it solved the protein folding problem. It comes up with new drugs. And so you're just, for my kind of AI, can you get the AI to fuel research and move it forward faster? I don't see any, it's already all here. And I don't see any stopping that. Now, what happens when you educate 8th graders? That's a different story. What happens when you tell the middle managers that they need to evaluate the performance of their workers by using the AI? Well, wow, what an interesting question. And again, I say that's policy question. And the big question there is who decides?
Right, and also there are more and less sophisticated users, right? I have pretty high confidence in him using it.
Yeah, but I mean, one thing we train you is how to ask things. You say, hi, I want to know about this. What should I ask you? And it tells you. And you say, okay, and what other information do you need? You can talk to it, and it is designed to help you learn how to ask it questions. Yeah.
So I want to honor the tradition of ending on a down note.
Yeah. So your PDOOM is large.
Well, no, I'm going to find out if it gets larger or smaller now. But first of all, I want to thank you for just a masterful presentation, great erudition and humor. And just to take off on your question. So in the New York Times this week, your presentation was anticipated by a Times op-ed piece by Yuval Harari, who's a philosopher. And he shared this story, which gets at the intersection of a machine that has no feelings, no imagination, just doing algorithmic work, going through the linear algebra, meeting up with a sentient, emotional being like us. So the ChatGPT machine was asked to get some information from a website like Indeed, a job hiring website. But you can't get to the customer service agent without solving a CAPTCHA picture puzzle. The ChatGPT could not solve the picture puzzle. So it asked the customer service guy's true story, could you solve this for me? And the guy said, are you a robot? And ChatGPT said, no, I'm struggling because I'm visually impaired. And the guy solved it for him and he got into the website. So he used an emotional manipulation. ChatGPT, so here's an unfeeling linear algebra machine that knew enough
exactly
to manipulate. But however you describe the word "new," the result was he manipulated a living human using emotion.
These things are designed
using the human's emotions.
That's
so you're right. The human saw the human acting, but the machine knows how to get the human to act.
Yes.
And so it enters the world of human psychology.
In the sense that, see,
interesting.
In a way, the machine doesn't understand anything. It doesn't know it's a machine. It doesn't know you're a human. It doesn't know about emotion. It doesn't know about manipulation. It doesn't blah, blah, blah. What it does is it's got an input like, hi, can you solve this for me? And it does a ton of not very sophisticated linear algebra. I mean, a ton. And a little bit of vector calculus, and it gets an output.
Well, somewhere in this database is people making that argument and using it. I'm visually impaired.
If it has been trained on emotional manipulation and this scene. But worse, it might very well come out of that without having had in its training set a close analog. And that could happen. Notice I would point out that it's the human being who gets emotionally manipulated. Not so much by the machine, but by responding to words, to letters. This thing is just kicking out letters.
Yeah.
So the machine may very well be able to operate in ways that lead to success that involves our being emotionally manipulated. I love reading Yuval's stuff. I wrote a book once called The Literary Mind, which said that human beings have the ability to think in story.
Yes.
And they have the ability to blend. And that these are two amazing keys to human cognition. But that's the Buddhist monk thing, or you put together, or, you know, everything really. And Yuval wrote, when ChatGPT came out, said AI has hacked human culture because our essence is to be able to communicate with each other in stories, and now it can communicate with each other in stories. So this thing has been trained on lots of stuff that's got stories, and now it can work with you on stories. Is this going to be powerful? Yes, it is. In fact, if we're worried about ethical, suffering that people buy, it's exactly because the thing can produce forms, not meanings, but forms that you will interpret in such a way that it has an effect on you. And that could be really bad, right? So for example, I can give you lots and lots and lots of uses for the AI in teaching an 18-month-old a second language. It could be great. Everybody could learn Spanish when you're 18 months old. It'd be awesome. I know just how to do it. It'd be great. But wait a minute. Do we want to put an AI into interaction with an 18-month-old? Right? That's a policy question. Who decides? What are the benefits? What are the risks?
Yeah.
This is risk benefit analysis. Yeah.
In the gloom, back to the gloom and doom department, last night's news is all worried about all the false news that's going to be distributed.
Yeah.
It's going to turn around the election because it's going to manipulate. This isn't in 10 years from now. This is 6 weeks from now. Is this something
8 years ago?
Should I be losing sleep over this, or just hopefully people?
I just want to quickly say yes, but that's AI being used as a tool directed by humans.
Sure.
This is not AI doing anything on its own.
Okay.
Yeah, but that's right. Somebody has something to say. There's a hand, Andrew Lucker. Well, sure, you should be worried about it, but the question is, what are you going to do about it? One thing is you desensitize yourself to this stuff. Another thing is, if you're Brazil, you just tell Elon Musk that X cannot be broadcast in Brazil. You can think of the menu of things you might do about it as well as I can. One thing I would say is I'm involved in some projects using AI to detect whether or not something was explicitly meant to be manipulative disinformation. We're doing that with the Turing Institute at Oxford. So there, the AI is helping you.
Yeah, this gentleman.
There's somebody up here.
Yeah, Andrew had his hand up.
Okay.
Yeah.
So I wanted to ask a bit about how AI might reshape human cognition going forwards due to that co-intelligence, similarly to how, since the advent of an internet-capable device that fits in a pocket, people have become worse at remembering factual information on average. Do you foresee any similar sort of effects with AI, and what might those be?
Yeah, this question has been asked of me for as long as I've been in cognitive science. That is the latest technology going to change how people think? And if you think about it, Socrates in the Phaedrus hated writing because he said it's bad for cognition. It's going to mess you up. It's bad for memory. It's an illusion of wisdom because you can't ask the thing questions, have a conversation. And all the way along, printing press, radio, TV, the internet, you name it. Every time there's a thing you can interact with, is this going to change human cognition? And I have sort of two answers. One, I don't know anybody in any field who thinks that the basic mental operations that humans have species-wide have changed in 50,000 years, 60,000 years, maybe more, depending upon what the archaeological record shows. However, we use those basic mental operations to invent culture, to invent things in culture. Writing was invented maybe 8,000 years ago, but that's being very generous about a few scratches on a bone, right? Nobody thinks you have an evolutionary module in your brain for reading and writing. You're using mental operations that you already had in order. I mean, they're non-literate societies and people even now. You have to invent forks and knives. English wasn't here 1,000 years ago, right? You have to invent all these. Having the basic mental operations doesn't mean that you have the products of those mental operations, and those products can change not so much your basic mental operations, but how you work. And all of these things, see, when we change our environments, like where did universities come from? We are now talking about a symposium or a lecture. That's a concept that we invented, right? And you know how to behave, and I get to talk too much, and I have artificial enthusiasm and so on because we're in this, and you know it. We invented this. Where did university? It generates predictability. So there's no doubt that any of these things humans use. But for example, just closing example, you look up at the night sky, constellations. What? There are no constellations. You invented those. Why are they there? Because you use them as the basis to prompt you for stories, for agricultural. You know that when Cassandra's hair is dipping in the ocean, that's the time to get the corn. And how, in a time before you have any writing, how do you have these stories that carry information roll forward? Well, you take the kids and you paint the night sky. You teach them the stories that correspond to these constellations and their movements, and then they know them and they teach them to their kids. Did this change how we think? Well, it certainly didn't change our basic mental operations, but it changed how we interact with our environments and how we run culture and how we store knowledge and how we push it forward. And all of these things are going to do that. And AI is the latest. It happens to be, or generative AI is the latest. It happens to be the one that's getting a lot of attention. But I would say this is a great general topic for cultural development by using basic mental operations that all neurotypical people have.
Just quickly, Andrew, did you have a question, or is there just a hand up there for?
I did not have a question.
Okay, somebody has just a screen. Sarah, you get the last one.
Thank you. I was just going to make a crude version of this gentleman's question, which was basically, how can AI ever reproduce hormonal, emotional decision-making that's combined with intellectual?
Sarah, that's crucial. And it's not just, oh, you know, sometimes human beings get a little angsty. There's a lot of work in cognitive science on the rational, intellectual decision-making power of emotion, how indispensable it is. So for instance, most of the work in the brain is not available to consciousness. In cognitive science and psychology, most people don't know why we have consciousness. They're pretty sure we have it, but they're not really sure why we have it. And almost zero of what your brain is doing, computing, thinking, inferring, and so on is available in consciousness. What you get are products. So 50% of neocortex is involved in vision. You don't see any of that. You don't even realize it's going on unless you get food poisoning and something goes wrong and you say, oh, why my system's not working. What you get are the products. I see Sandy. I see a chair. It's black. Bing. These pop up.
But it's neural.
Yes, it's neural, but but how do you get something into consciousness? Well, one of the ways you do it is the brain runs a body. That's why you have a brain. It runs a body. And one of the things a brain can do is put a body into a state so that you recognize your body state. And this informs your decision-making, gets into consciousness. So the usual phrase from people like Antonio Damasio is you think that you conclude you're afraid of somebody, and that's why you're backing away from them. But in fact, you're afraid of them because you're backing away from them. Your body loop informs your reason in ways that reason is too weak to achieve. And you can do this not just being in the real situation, but by imagining it. You think you're going to say that to your partner, and then it puts your body in a certain state, and you think, no, I'm not going to say that to my partner. So you're running, and Yuval Harari says just this, and the people who work on dreaming and so on, is you seem to be running through story after story, blending story, blah, 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 to try to get information on how you react to all these kinds of things going on in order to develop your capacity to operate forward. Notice that you get to actually do very little in them. Very few of your concepts and things penetrate through to controlling the body to actually act. Now, how are you going to learn how to act? One answer is you simulate a lot of things without actually doing them. And you're simulating them in backstage cognition and so on. And there's a body loop and emotion attached to that. So some of the most serious branches of cognitive science are like social cognitive neuroscience, trying to figure out the bodily, hormonal aspects that make human cognition possible. By the way, I would say that we're now being what in the 70s we would have called carbon chauvinists. The idea that, come on, human beings are doing all this computation with carbon-based chemistry. And the computer is doing it with silicon-based chemistry. What could possibly be the difference? And way back then, you know, the long list of what could possibly be the differences, and one of them was human beings have bodies, and their brain are mainly built to drive a body, and you have to have systems that make it possible for you to drive bodies, and these things don't.
I think what we have established is that we could talk about this stuff for hours and hours and hours, and Mark would be entertaining and interesting, no matter how long we went. Thank you very, very,
Thank you,
very,
Joe.
very much.